All right, section 8.5 is on exponential growth functions. And by the end of this day, you should understand the basic model or formula for an exponential growth equation and how to go ahead and graph it. So those are really our goals today. So something grows exponentially if it's increasing by the same percent in through time. This is our equation for exponential growth. A equals P times 1 plus R to the T. A is the amount that you have at the end. P is the amount that you start with. R is the percent of growth, and T is time in years. So that's what each of those formula or each part of the formula mean. A the final amount. P the initial amount. 1 plus R is the growth factor, the growth rate is the R. And T is in time, usually in years. If we want a percent increase, that's always going to be 100 times R. So here's an example problem. This is an example of exponential growth. We're taking some money, we're putting it in the bank, and it's going to earn interest, and it's compounded. The compounding is what happens to make it exponential. So what's our model? How much will the money be worth in 5 years? If we put 1,000 in now, how much money will we have in 5 years? So we start with the 1,000 is our starting amount, so that's the P. The 6.5% goes in as 0.065 in where the R goes, and the A, we use the Y value because this is our exponential function here. T is time, so that's where we're going to put the 5. 5 goes into T. So 1,000 times 1.065 to the fifth ends up being 1,370.09 or $1,370.09. And that's how much we would have at the end of 5 years. Another exponential example is going to be a bacteria growth. So let's say we start with 100 bacteria, and we say that they're going to double in number every hour. What's the model, and how many are there after 8 hours? Now, what may look different about this one is that they don't give you a percentage. Or do they? So what does double every hour mean? Well, double every hour means that what's inside the parentheses is going to be a 2. And since we have 1 plus R, we know that R has to be 1 in this case. If we plug in 8 for the T, then we're going to get about 25,600, which is why this is the example of why you want to brush your teeth in the morning, because after you've been asleep for 8 hours, that's how many extra bacteria there are in there. Now to graph this, all we're going to do is make a T-chart, just like we would for a linear equation. So I'm going to plug in numbers for T. Our inputs are T, our outputs are Y. When we plug in 0 for T, we get 2 to the 0 power, which is 1, times 100 is 100. We plug in 1 for T. 2 to the first power is 2 times 100 is 200. We plug in 2 for T. 2 to the second power is 4 times 100 is 400, and so on. And so we have our table. We got our table of values, and now we're going to go ahead and plot them and put a smooth curve to them, and that's the graph of exponential function.